In today's lesson, we're going to be focusing on law of sines. So, law of sines, as you guys learned in trig, is a way that we can use trig ratios for non-right angles. So, for any triangle, the ratio of the side to the sine of the opposite angle is going to be equal. So, A over sine of A, B over sine of B, C over sine of C. They're always going to be equivalent. So we can use this in certain situations to be able to find the missing sides of a right triangle, or any triangle for that matter. So let's look at an example. All right, here we can see that we have angle B and the angle across from it. The side across from it is 15. So when we set up any proportion, all right, we know that we can use 15 over sine of 25 degrees. Now the other thing here is that we have two different angles. We have 107 and we have 25. So to find a third angle, I can add them together. 107 plus 25 is 132, and then subtract that from 180. So that means that the third side is going to be 48 degrees. Or third angle is going to be 48 degrees. So I have all three angles. So that means I can find these other two sides. So for one of our equations, we can set 15 over sine of 25 equal to C over sine of 107 degrees. Or I could say 15 over sine of 25 is going to be equal to A over sine of 48 degrees. So now I want to get these by themselves. So in order to do that, we're going to multiply both sides in the first instance for C by sine of 107. So that's going to cancel out. So we're left with C is equal to 15 sine of 107 divided by sine of 25. Now you're going to want to make sure that your calculator is in degree mode, and then you can type in 15 sine of 107 divided by sine of 25, which is approximately 33.94. All right, we can do the same thing for finding the length of side A. We're going to multiply both sides by sine of 48. All right, so in doing so, those are going to cancel out. So we get A is equal to 15 times sine of 48 divided by sine of 25. So again, you put that into your calculator, make sure you're in degree mode, and you get about 26.38, which all makes sense because as the angles are getting bigger, the sides are getting bigger. All right, let's look at example 2. All right, so in this case, we have two angles in the side in between, but we don't have anything across from each other. So it's kind of hard to set up that proportion. But since we have two angles, we can add 115 to 30 to get 145, and then subtract that from 180 to get this missing angle A to be 35 degrees. So that means we're starting with our base ratio of 30 to sine of 35 degrees. So now our possibilities are going to be B over sine 30, or C over sine of 115. Alright, so when solving for B, we need to multiply both sides by sine of 30. So we get B is equal to 30 sine of 30 divided by sine of 35. So again, type that into your calculator, 30 sine 30 divided by sine of 35. Make sure that you are in degree mode. So B is going to be roughly 26.15. Solving for C, we're going to multiply both sides by sine of 115. So C is equal to 30 times sine of 115 divided by sine of 35. Same thing, we're going to go ahead and substitute that in, put that in our calculator, and we get C is roughly 47.40. All right, and again, I want to make sure that as my angles are getting bigger, my sides are getting bigger, which they do. So now we're going to go on to our last example, and here we have two sides and an angle. So we can start with, as our base, 22 over sine of 120. Now this one we're going to have to do a little bit more work. All right, because what we're missing here is we don't have an angle B. So we're going to start by finding angle B. So we're going to set that equal to 15 divided by sine of B. Now here, because we have the variable in the denominator, we want to cross multiply first. So that means we get 22 sine of B is equal to 15 sine of 120. And we want to divide both sides by 22 to get sine of B by itself. But then we need to use the arc sine. So B is equal to the arc sine of this entire expression, 15 sine of 120 divided by 22. So when we go ahead and put that into our calculator, we get, so 15 sine of 120 divided by 22. We get that B is going to be roughly 36.19 degrees. So now that we have that, we can go ahead and take 36.19, add that to 120 to get 156.19, then subtract that from 180, and we get that angle C up here is going to be 23.81 degrees. All right, so now we can set up a ratio to solve for the length of side C. So we're starting with 22 over sine of 120, and that's going to be equal to C over sine of 23.81, sorry. Alright, so when we go to solve this, multiply both sides by sine of 23.81. So these will cancel out, so we get C is equal to 22 times sine of 23.81 divided by sine of 120. So we can put that into our calculator. Again, making sure we are in degree mode. And we get C is approximately 10.26.